All right, so this is in what form? Vertex form, right. So you know your vertex is going to be 1, 7, because that's my H and my K. And then your A value is negative 3. So that's really all you need to know to graph it. So the first thing you're going to do is plot your vertex at 1, 1, 2, 3, 4, 5, 6, 7. Okay? This is going to open down because of this negative here. That tells me it's going to open down. And remember, basing off this off the graph of x squared, which goes over 1, up 1, over 2, up 4. This was this unit. All right, so from here now we want to just multiply all our changes in y by negative 3. So I'm going to go over 1, down 3 instead of up 1, so 1, 2, 3. And I'm going to go over 2 instead of going up 4, down 12, because it's going to be negative 12. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And you'll be given nice grids to do this, so it won't have to be, you won't have to worry about making the graph. You go down 12 because you're going down negative 3. Typically you go over 2, up 4. But so you multiply the up 4 by negative 3 and you get negative 12. So for number 6, it tells you to solve using quadratics, I believe. So the first thing you want to do is isolate x squared, if you can. So using square roots. So you want to get this all by itself. So first subtract 3. So you get negative 1/4 x squared equals negative 8. And again, we want to get x squared by itself, so I multiply by negative 4, multiply by negative 4, and you get x squared equals 32. And then from here, this is where you take the square root. So you get x equals plus or minus root 32, and that simplifies to what, 4 root 2? Okay, yeah, so for number 8, you're going to want to solve using square roots again, so you want to isolate whatever's being squared. So we have to get this all by itself, and then we take the square root. So you subtract 9 from both sides, so you get negative 5. X plus 1 squared equals negative 9. Divide by negative 5, so you get x plus 1 squared equals 9/5. Alright, and from here we now have just this being squared, so we can take the square root of both sides. So you'd get x plus 1 equals plus or minus the square root of 9/5. And if you want, you can simplify the square root of 9/5. I'm not too worried about it. This would be alright, I'll go over it. So then you can just subtract 1. So you get plus or minus the square root of 9/5 minus 1. Here the square root of 9 is just 3. So you'd get x equals plus or minus 3 over root 5 minus 1. And then remember, we just have to rationalize the denominator. So you'd multiply by root 5, multiply by root 5, and you'd get x equals plus or minus 3 root 5 over 5 minus 1. For number 9, anytime you're doing these simplifying or anything or solving with imaginary numbers, I would just treat I as a variable until you get to the end and then solve. That will make it easier, I think, for you guys to solve these. So first you just distribute. So you'd get 10 plus 15I minus, and then this has to be squared. So it's 1 minus 2I times 1 minus 2I, which would be 1 minus 4I plus 4I squared. Alright, and then we're just going to distribute this negative. Minus 1 plus 4I minus 4I squared. I can combine like terms. So 9 plus 19I minus 4I squared. And what does I squared equal? Right, negative 1. So that's going to be 9 plus 19I minus minus 4 is plus 4. So your final answer would be 13 plus 19 I. 10's the same thing. Here we're just going to distribute, so you'd get 24 plus 18I minus 8I minus 6I squared. Combine like terms, you get 24 plus 10I minus 6I squared. Just I squared right here equals negative 1. Only I squared equals negative 1. So you get 24, this should have an I here, plus 10I minus negative 6, so that's plus plus, so you get 30 plus 10I. For number 11, when you have an imaginary number over an imaginary number, this is where we have to multiply by what we call the complex conjugate. The complex conjugate is just you multiply by the denominator, but you change the sign in between. Okay, so that's the complex conjugate, 5 plus 2I. So all I did was multiply by the denominator with this sign. Just change the middle sign, yeah. That's when you have an imaginary in the denominator, yes. Alright, so again, you're just distributing this. So you'd get 10 plus 4I plus 15I plus 6I squared. Over, you can distribute this. What it ends up being is 25 minus 4I squared. And then we just need to simplify from here. So you get 10 plus 19I plus 6I squared over 25 minus 4I squared. I squared equals what? Negative 1. Very good. So you get 10 plus 19I minus 6 over 25 minus 4 times negative 1. It's going to end up being plus 4. So you get 4 plus 19I over 29. So to complete the square, the first thing you want to do is get in x squared plus bx form. So I'm going to subtract 1. So I get x squared minus 5x equals negative 1. And from here, you're going to add b over 2 squared to both sides. So x squared minus 5x plus b is negative 5 over 2 squared, and negative 1 plus negative 5 over 2 squared. All right, and remember remember that when you are completing the square, rather than having to multiply this out and find what the factors are, you can always just get x plus b over 2 squared. So that would just be x minus 5 halves squared. That's much easier than multiplying this out and trying to find the factors. So then you get negative 1 plus 25 fourths. All right? X minus 5 halves squared equals 21 fourths. And then from here, we're just solving. So you take the square root. X minus 5 halves equals plus or minus root 21. Square root of 4 is 2. And then you just add 5 halves. So your final answer would be x equals plus or minus root 21 over 2 plus 5 halves. So 15 asks you to find the discriminant, number of solutions, type of solutions, and what the solutions are. So remember, the discriminant comes from the quadratic formula, which is negative b plus or minus square root of b squared minus 4ac over 2a. The discriminant is just what's underneath the radical. So the discriminant is what I'm putting in a box here in red. That's the discriminant. So for this problem, the discriminant, well, first I would actually rewrite this as x squared minus 3x plus 10. So it's in the ax squared plus bx plus c form. All right, so it would be b squared, so negative 3 squared minus 4 times a times c. So you'd get 9 minus 40, which equals negative 31. So that's your discriminant. So is negative 31 greater than 0, equal to 0, or less than 0? So what kind of or how many solutions? Two, what kind? Imaginary. And the last step to find the solutions, we just plug everything into the quadratic formula. So you get x equals 3 plus or minus the square root of negative 31 over 2 times 1, which is 2. So when you have a negative under a radical, remember you have to pull out an I, and that'll make it positive. So your final answer would be 3/2 plus or minus I root 31 over 2. For these, it wants you to put it in a quadratic function. This would be easiest to put in vertex form, which is just a x minus h squared plus k. And remember, our vertex is hk. So to find h and k, all you have to do is plug in 1 and 3. So you'd have y equals a x minus 1 squared plus 3. So now all I'm missing is my a term. And lucky for you, they give you a point, 2, 5. So I'm just going to plug 2 and 5 in for x and y and solve for a. So you get 5 equals a, 2 minus 1 squared plus 3. All right, and then we just solve. Minus 3, 2 equals a, and you're done, really. Solve for a, so your final answer would be y equals 2, x minus 1 squared plus 3. So 19 gives you x-intercept, so you're going to want to put it in intercept form, which is y equals a, x minus p, x minus q. So again, you just plug in your zeros. So y equals a, x plus 6, x minus 7. And again, they give you a point, 2, negative 80. So you're going to plug that in for x and y. 2 plus 6, 2 minus 7. So you get 80 equals a times 8 times negative 5. So negative 80 equals a times negative 40. Then you just divide by negative 40. And you would get a equals 2 again. So from there, you just plug a back into your equation. X plus 6, x minus 7, and you're done. All right, so when you're given 3 points, that's when you have to put it in standard form. So to put it in standard form, remember we want to put all 3 of these points in ax squared plus bx plus c. Yeah, this is where you use a matrix. So you get the first one, ax squared, so you're going to have a times negative 2 squared plus b times negative 2 plus c equals negative 9. All right, so I can work that out, and I'd get 4a minus 2b plus c equals negative 9. So that's how I'm coming up with these values. I can do the same thing for these two. 0 squared is 0, so I get 0a plus b times 0 is 0b plus c equals 1. And the same thing here, 1 squared is 1a plus 1b plus c equals 3. So I've put it in to a system of equations, and from here you simply have to put it in a matrix and solve. So this would become, and I'm just taking my coefficients from here, so 4, negative 2, 1, 0, 0, 1, and 1, 1, 1. I'm solving for a, b, and c, so a, b, c, and that equals negative 9, 1, 3. And from there, here you have a, you have x, and you have b. So to solve, you would just do x equals inverse of a times b. And that would give you your solution. For 21, it's talking about an impala, and it gives you an equation, and it asks you to find its how high it can jump and how far it can jump. So first off, we can see that this is a quadratic equation, right? The negative out front tells us that it opens down. So you know that this Impala's flight is going to look something like this. All right, where is it going to jump its highest? In the middle at its vertex. And how can you tell how far it can jump? What do you need to look for? Right, your zeros. So the zeros are probably the easiest thing to find first. We're just going to set this equation here equal to 0. So you get 0 equals negative 2/45 x squared plus 4/3 x. All right, you can subtract by 4/3 x and solve that way, but I think it's easier to factor out in x, right? Both of these have an x in them. So you can factor out an x. Negative 2/45 x plus 4/3. And now we have two multiples being set equal to x, so we can set each of them separately equal to x. So you would get x equals 0 when I said this, and then you'd get 0 equals negative 2/45 x plus 4/3, and then you would solve. So subtract 4/3, and then multiply by 45 over negative 2. All right, and I believe you get 180 over 6 equals x, so x equals 30. So that tells you how far the Impala can jump, 30 feet. Once we have our x's, we can easily find our vertex. What would the x coordinate of my vertex be? 15, right? Because I jumped from 0 to 30. So this is 15. And then to find how high it can jump, you just have to plug 15 in for x into your equation and solve for y. So you'd get negative 2/45 15 squared plus 4/3 times 15. And you could plug that in your calculator and solve. All right, so I'm going to go through 22 relatively quickly. I have like 6 minutes, so it should be all right. 5 minutes. All right, so whenever you're doing these problems, this type of problem, you always want to subtract the biggest area from the parts that you don't want. Okay, so that's ultimately how you're going to do any kind of these problems, the picture frame, whatever it ends up being. So here it tells me I want to double the area of this parking lot. So if I want to double it, I first need to find out what that area is. So to do that, I'm going to take this area here, which is 375 times 240. So 375 times 240, and that's 90,000. So that's the area of the blue. And then I need to subtract the area of the school from that, which is 300 times 165, 49,500. So you end up getting for the area of just the old lot, 40,500. And that's the area old lot. So if I want to double this area of the old lot, that means this expanded lot has to equal the same as it. Okay? Because if this expanded lot equals 40,000, then I've successfully doubled the area of the old lot. So I know it has to equal 40,500. That's what I want this lot to be. So now all I'm doing is trying to find the area of that old lot, which is just the orange, right, which is going to be this distance here would be 240 plus x. This distance here would be 375 plus x. And then I have to subtract the blue from that, because that'll give me the area of just the expanded lot. So the blue is 90,000. So what I do is 375 plus x, 240 plus x, minus 90,000. Sorry. I forget how long this equation is. All right, so that's how you would set up the problem. So from here, you just have to solve. So you'd end up getting x squared plus 615x minus 40,500 equals 0. And you just have to factor. So you have to find two numbers that that multiply to negative 40,500 and add up to 615. And those are going to end up being x plus 675 and x minus 60. They cancel out. 375 times 240. So your answer would be 60.